Our startup was born around a research project because we saw that nowadays a lot of e-waste are recycled by pyrometallurgy, and it emits a lot of CO2, it consumes a lot of energy, and it's an oligopoly of some countries, and the other countries can't use their own resources. So we wanted to build an agile process that can be implemented directly on the country or point of production of the e-waste. So we were working on an hydrometallurgical processes, and that's when we thought about creating a startup just to use this process for other people, make it available for other countries, and also developing other process for wastes that contain metals. And in that way we can be more self-sufficient in Europe, for instance. WEEEMET is designing a unique and innovative process to recycle metals from e-waste, mainly, but it can also be multi-material. And we are relying on liberating the metals from the other material, which can be ceramics or glass, fibers, etc., plastics also. And we are using hydrometallurgy to valorize the metal. Currently, the e-waste are treated by pyrometallurgy, and it's a high temperature and really energy-intensive process to recover only copper and precious metals like gold and silver. But the e-waste contain also a lot of metal like aluminum, zinc, tin that are really useful, and some of them are strategic and critical for the Europe. The main challenge is at the beginning of the process, which is the sorting, the collection of the waste, and their characterization. The feed is really complex and heterogeneous. So if the cards were produced 10 years ago, or if they are produced now, their composition varies a lot. Now we have less and less gold, for example, in the PCBs, because it's really high price, and so it's difficult to have a homogeneous field for the process. But after, it's also difficult to characterize the metal that we have. For instance, gold or PGMs are very low concentrated compared to copper, so we have a very accurate analysis of copper. But when it's turned to gold, it's really difficult to have accurate analysis and representative sample. But it's the most part of the value. So this is really challenging for the recycling in general, all sectors facing this kind of challenge. I think the most important thing will be to have a site, a place to implement the startup after leaving the incubation lab. Because when we are leaving the lab, it's really difficult to find sites that are suitable to do chemistry at a low price for the startup. And in some region, we can find some shared buildings, shared sites built by the city or the region to welcome startup and help them developing by sharing the costs of the building, for example. So we can share labs and have our own office, and it also enhances synergy between companies. So it's really great, and it will be great to have this around us. For my side, it will be to not limit yourself into one field or one skill. Like there is so much thing you can learn for valorize the metals, but also concerning all the circular economy. There is social fields, environmental fields, there is mineral processing, but also chemistry. For instance, I was graduated as a geologist, and now I'm doing chemistry in my everyday work. I'm kind of chemist. So it's really interesting to mix the origins and the skills. So just if you are curious, don't hesitate to learn everything you can that can help to enhance the circular economy.